In this question, we'll calculate average atomic mass. This question says an element has the following natural abundances and isotopic masses. 90.92% abundance with 19.99 AMU, 0.26% abundance with 20.99 AMU, and 8.82% abundance with 21.99 AMU. To calculate the average atomic mass, we'll take the percent abundance times the AMU. The first part of the question says we have 90.92% abundance with 19.99 AMU. Let's begin by starting from the 90.92. And remember that the words percent mean divide by 100. Per means divide, and cent means 100. So we'll divide this by 100 and multiply by the AMU, 19.99. When we put this into a calculator, we get 18.17. We'll repeat this process for the next isotope, 0.26% abundance with 20.99 AMU. So we'll take 0.26, divide by 100, and multiply by 20.99. And we get 0.0546 when we enter this in a calculator. For the third piece, we'll take 8.82% abundance with 21.99 AMU. Start with 8.82 and divide by 100, and multiply by 21.99. In the calculator, we get 1.940. Now, add all of your answers together. So we'll begin with 18.17 plus 0.0546 plus 1.940. When we enter these, we'll get 20.16 AMU for our average atomic mass. In this question, we'll find the molecular and empirical formulas for these molecules. Let's begin with the molecule on the left. First, let's count how many carbons are in this molecule. We see 1, 2, 3, 4. So to begin, we'll start with the letter C and write 4 as a subscript underneath it. We also have hydrogen, so we count the hydrogens. 1, 2, 3, 4, 5, 6, giving us a formula of C4H6. This is the molecular formula. To get the empirical formula, we need to think of a number that will divide 4 and 6 evenly. Well, the number 2 will divide both of those numbers evenly. So we'll write 4 divided by 2 is 2, and 6 divided by 2 is 3. Therefore, the empirical formula would be C2H3. Let's try the molecule on the right. We have 2 silicons. We'll begin by writing Si, and because there are 2, we say Si2. We also have 2 hydrogens, and we'll write H2. Now there are 4 chlorines, so we'll write Cl4. This is our molecular formula. Now to find the empirical formula, let's think of a number that divides all of those numbers evenly. So 2 seems like a good thing to try again. So for silicon, we have 2 over 2, which is 1. For hydrogen, we also have 2 over 2. That's 1 as well. For chlorine, we have 4 over 2, and that's 2. Now remember, when we write a formula, if the number is 1, we don't have to write a number. Now, ordinarily, you might think that you're writing Si1H1Cl2. However, in chemistry, we don't write the number 1. We just write the symbol by itself. So the correct empirical formula is SiHCl2. So once we get the molecular formula, the empirical formula is the formula that is in lowest terms. Now, if we could divide by something else to get the numbers lower, we would. But with this particular formula, this is as far as we can go.